Hi, and welcome to video 3 for section 5.2. This is the third and final video. As you can see, I still have the last problem from the second video up on the board. As I thought about it, I figured, you know what, I'll just show you the shortcut now. It won't be the full detailed shortcut, but it'll give you the idea what you're supposed to have to do. So if you do want to get into this homework before watching the videos for 3, you'll still be able to. So here is the shortcut, and again, I'll go into much more detail in future videos, but much like I did when we were talking about derivatives, I showed you the shortcut right off the bat to make your life a little easier. You're going to learn this when we're trying to calculate an integral, the value of an integral. What we're going to do is take the antiderivative of what's inside the integral here. So the antiderivative of this is what? Well, we're going to add 1 here, 4, divide by that number, so 1/4, minus the x, we raise it to 2, 6 divided by 2 is 3. And now we change this sort of elongated s to like a bracket on the end here and put a 3 and a 0. Actually, it doesn't, it's just a line. It's not even a bracket. Line, 3 to 0. And what we're going to do is we're going to plug 3 into this function minus, so it's this value minus this value plugged in. So let's do that. If I plug in here 1/4 x to the, so 3 to the 4th minus 3 times 3 squared minus, now plug 0 in, 1/4, 0 to the 4th minus 3 times 0 squared. So if I do that, what do I get? 3 to the 4th, well 3 times 3 is 9, times 3 is 27, times 4 is 81. So that's 81 over 4 minus 3 squared is 9, times 3 is 27. So minus 27 minus 0 times minus 0, so just minus 0. So we get what? 81/4 minus 27 is negative 6.75. So you can see we didn't have to do all this crazy algebra, all the summation formulas. Now again, if on an exam your instructor says, don't use the shortcut, you got to do it the long way, then you're left with this version. But otherwise, that's the shortcut. So let me show you one more quick shortcut, just as an example. And as I said, you know, in the next videos we'll see it, but this is not in the book in this section. This is literally right now off the top of my head, just to give you an idea. But let's say we want to take the integral from 1 to 4 of x squared minus 2 dx. So I do what? Take the antiderivative of this, so this becomes x to the 3rd, divide it, so 1 over 3, minus 2x, and this is going from 1 to 4. So plug in 4, so 1/3, 4 to the 3rd power, minus 2 times 4, and it's this whole thing minus when I plug in 1. So 1/3 times 1 squared minus 2 times 1, and then you calculate that, and that's your answer. So that's the steps. Take the antiderivative, plug in the upper limit, subtract plugging in the lower limit. That gives you the answer that you want. So again, the shortcut method, you'll see it in full detail later, but at least to help you with the homework, if you want to save some time, that's how you do it. Alright, so now let's get on to what video 3 was really supposed to be, which is just a bunch of formulas really. It's the midpoint formula and then all the integral properties. Or the midpoint rule, rather. So the midpoint rule, and it's just expanding on this formula that we keep using. So we either had the left endpoint, or we had the right endpoint, or we had some random point when we were dealing with Riemann sum. This one, all we're saying is when we have the interval, take the midpoint of the interval, and that is what we'll use for our values. So the integral from a to b of fx dx is the sum, I is 1 to n, and yeah, this should be the limit. The limit as n goes to infinity, 1 to n of f of x bar I times delta x, where again, delta x is b minus a over n. So it's equal intervals. And then xi bar is just 1/2 of x I minus 1 plus x of I. So add the two endpoints, divide it by 2. That gives you the middle value. That becomes your xi. So again, it's nothing, it's just somebody else, probably their doctorate thesis, like, oh, nobody's taken the midpoint, so I'll do the midpoint and I'll make that my midpoint rule. So instead of the left endpoint or the right or a random value within the interval of random size, etc., you know, somebody probably made a ton of money by coming up with the midpoint rule. So it's the same idea, just picking a different spot. All right, so lastly then is the properties of definite integrals. So the first one is that if I have an integral f of x dx, but if I have b on the bottom and a on the top, that's the same as if I just take the negative value of a to b of f of x dx. So sometimes it's easier for us to switch our upper and lower limits. And so if we do that, we just have to make sure to take the negative of that value that we get. So the calculations might be easier, but then make sure you take the negative value once you're done there. Number 2, if we go from a to a of the function fx dx, well, if we go from 2 to 2, basically what's the area under that curve? Well, it's 0, right? So if our upper and our lower limits are the same value, it's 0. 3, the integral from a to b of a constant, integral of a constant, well, that's just, and this kind of goes to the shortcut that I showed you, right? If I have a constant, let's just call this 1. If I take the antiderivative, that's x, and then I plug in b minus a, what do I get? I get b minus a. I think there should be times c. Yeah. So c times b minus a, where c is a constant. If it was 1, then it would just be b minus a, but if it was any other number, 5, 8, negative 3, whatever, then we'd have to multiply that by that value. Number 4, the integral from a to b of f of one function plus another dx, this is just equal to the integral from a to b of f of x dx plus the integral from a to b of g of x dx. Number 5, it's basically the same as 4, but with a minus sign. So from a to b, f of x minus g of x dx is just integral from a to b of f of x dx minus integral of a to b of gx dx. Number 6, integral from a to b of some constant c times f of x dx is just c times the integral from a to b of f of x dx. And again, c is a constant. Number 7. The integral from a to c of fx dx is equal, so from a to c plus the integral from c to b fx dx is the same as the integral. So we have a c as an upper limit here, c is the bottom limit here. So we're essentially going from a to b. That's why I had that little pause there. I thought we were starting with that piece. So it's the integral a to b of f of x dx. And again, this one, you're more often going to see it going from here this way. So it might be easier to break up our integral a to b into two separate integrals, stopping at one point. So maybe like, let's say this was like -1 to +1. It might be easier to go from -1 to 0 and 0 to 1, and then evaluate those two integrals. So if we're like evaluating absolute value function, integral of absolute value function, something like that, it'll be easier to break it into pieces. Number 8, if f of x is greater than or equal to 0 for all, for a is less than x, less than or equal to x, less than or equal to b, then the integral from a to b of f of x dx has to be greater than or equal to 0. So if the function is greater than or equal to 0, for any of our x's between the interval, well then the integral itself is going to have to be positive. And think of that like the very first example we were thinking of when we had like the parabola from 0 to 1. Well, the whole function is greater than 0, so the integral is going to, the number, remember integral is a number, that number is going to have to be positive. Number 9. So if f of x is greater than or equal to g of x for x is between a and b, then the integral from a to b of fx dx is greater than or equal to the integral from a to b of g of x dx. And think about this like in the form of a picture. So let's say I have whatever, some function here. Let's call that g of x. And then I have some other function here. Let's call that f of x. Well, no matter what point x I pick along this interval, f of x is always bigger than g of x. So that means what? That means the integral of underneath the red is going to be bigger than what's underneath the black. So pictorially, that's what that statement is saying. And lastly, number 10. If the minimum, so we're going to write a little m here. So if the minimum value of the function, or if the function let me put it this way, if the function falls between two values, a min and a max, for all x between a and b, then if we take that minimum value, multiply it times b minus a, that's going to be a value less than or equal to the integral. And that value is less than the max number multiplied by the interval length. So that's it. So really this video started out as a bunch of formulas. As you guys have seen by now, I kind of do some stuff on the fly, which sometimes blows up in my face. That's okay. But in this case, I'm glad I did it. I'm glad I showed you guys that shortcut. I think it'll just, help simplify a lot of this homework. And we're going to get into it anyway, so you might as well see, here's the long way to do it, here's the way you should do it to save yourself some time. So that's it. Come on back, and we'll start on the section 5.3.